everybody is unique. And so everybody's treatment really has to be tailored to who they are. And the only way to do that is to get a really good understanding of how everybody works individually. And I can only do that by really testing on your samples, since I can't test on you specifically.
Jelani Clarke, Neuroimmunologist and Chief Business Development Officer at AminoChain.
In most jurisdictions around the world, it is illegal and highly unethical to run experiments directly on humans. And so the only way for us to really assess and leverage and understand what are some of the diseases or just normal physiological processes that plague humans is to use remnant human samples. We're moving away from animal models because they're useful in what they're useful for, but they don't really recapitulate the human physiology, the human system. They don't translate very well in most cases. And so you have to essentially use models that are closest to humans, and that is human-derived tissue, human-derived environmental models like organoids, and similar type of environmental models or microenvironmental models that we are now using. And so with that in mind, biobanks become even more essential because these are the places where we can go and get those assets to then develop these models to then understand disease pathology and whatnot. We're talking about longevity a lot. Longevity is a huge focus in the world, right? How do we extend the life of individuals beyond their, kind of fight against aging? And that's fantastic. But it's a little bit misplaced when people are still dying from preventable diseases. You can extend the net lifespan of the population, not just individuals, but the net population, by taking some of the allocated funds that are going towards these kind of life extending and redistribute it to places where people are dying from things that can be prevented.
Bonded by Science, proudly presented by Noble Blocks.
All right, Jelani, thank you so much for joining us on Bonded by Science. It's really a pleasure to have you here. I'm very excited to hear about what you're working on and your future vision of healthcare and how that relates to biobanks in particular.
Thank you, Shelly, for having me. It's always nice to be on a podcast with a fellow scientist, talking about hopefully cool stuff that people don't really know about. Yeah, I think it'll be a good conversation.
Super. Well, why don't we just kick it off with maybe you can just briefly define what is a biobank generally? If someone was to ask you, maybe you're at a family friend's party and someone says what do you do? And you'd be like, oh, well, I help establish biobanks or I connect biobanks. And what would you be referring to there?
So a biobank is a repository. So it's a place to store biological assets. And that can be physical assets like tissue, so blood, cancer biopsies, saliva, what have you, dissected finger, as well as accompanying data, so genetics. So you can have genetic sequences, omics data, all that kind of stuff. Anything revolving around biological assets that are stored in a secure location or in a location is considered to be a biobank or a biorepository. Now, this doesn't have to be necessarily just human. It can be environmental as well. You have seed banks for people who are storing plant seeds. You have animal banks that store animal material. So that is what is considered to be a biobank, essentially a bank, like a financial bank, but for biological materials.
Right. And so I really like that you brought up that the biobank is not just for healthcare, but it's for the welfare of our environment. So for example, the biobanks that harvest a lot of seedlings. And I guess there's probably many other types of biobanks that even you and I would be unaware of that exist out there. But I think for the most part, I know that you're particularly interested in biobanks that are connecting biosamples or data that has some relevance to us as individuals. I'm quite curious to hear about your impression of the attitudes related to healthcare biobanks. So biobanks revolving around healthcare. Do you find that they are generally positive? Are they negative? And I'm not talking about other scientists. I'm talking about people that you would meet on the street.
I think most people are not aware of biobanks. I know most people are not aware of biobanks. A lot of people in the medical industry or in the scientific realm are also not aware of biobanks, despite the fact that biobanks have been around since I mean, technically for as long as we've been doing research, but more officially in official capacity since we've seen an explosion in biobanks since the early 1980s, like a massive, like an exponential increase in biobanks. So they've been around for a long time, and they're essentially a cornerstone and a growing cornerstone to how biomedical research gets done. But I think the general public and even just the general scientific public doesn't necessarily understand what a biobank is. So this is a good opportunity for us to kind of shed light on why they're important and what position they play in innovation and biomedical research.
So what would you tell those people then? So like if we were to say, okay, well, this is a biobank, you've defined that already, but what would you say, like, what's the future role now of biobanks? They've been established for a long time. I would imagine the intensity of their establishments are growing, but what future role will biobanks have for us, like for you and me and maybe our kids?
Yeah. So the way I like to present on biobanks is from the lens of in most jurisdictions around the world, it is illegal and highly unethical to run experiments directly on humans. And so the only way for us to really assess and leverage and understand what are some of the diseases or just normal physiological processes that plague humans is to use remnant human samples. So there's a realm in science that leverages animal models. But I think if anybody who's been attuned to the scientific kind of paradigm, we're moving away from animal models because they're useful in what they're useful for, but they don't really recapitulate the human physiology, the human system. They don't translate very well in most cases. And so you have to essentially use models that are closest to humans, and that is human-derived tissue, human-derived environmental models like organoids, and similar type of environmental models or microenvironmental models that we are now using. And so that's the best way that those are the best tool sets and toolkits and assets that we can use to better understand the things that plague us and how we work. And so with that in mind, as we move further and further away from leveraging animal models and technology advances in such a way that we can grow organs on chips and we can grow these organoid models, biobanks become even more essential because these are the places where we can go and get those assets to then develop these models to then understand disease pathology and whatnot. And so if you think about the realm of precision medicine, so that's another kind of paradigm shift that's happening in the medical field, where instead of having generalized therapies or generalized applications of medicine, we're becoming more and more tailored towards an individual, and we're understanding that everybody is unique. And so everybody's treatment really has to be tailored to who they are. And the only way to do that is to get a really good understanding of how everybody works individually. And I can only do that by really testing on your samples, since I can't test on you specifically.
Right.
And where do I get those from? Clinical sites and biobanks.
Okay. So you said there was a few keywords that you said. One. So I want to just backtrace a bit. So one was the word organoid, and then you said growing it on a chip. So can you just explain that briefly to some listeners that may find that particularly interesting? It's very sci-fi like.
Yeah, sure. So an organoid is essentially a grown organ outside of a body. So you can take, for example, a liver biopsy, and you can essentially grow a mini fragment of a liver outside of the body on a chip, which is kind of like a slide that has, the environment that would facilitate the growth of that organ or that mini organ, pseudo organ. And then you can run experiments on, how do livers work? How would a liver respond to this kind of treatment? What are some disease models? You can generate a cirrhotic liver and then look at therapies against it. So that's what an organoid is. Oid meaning pseudo. It's a kind of organ. It's a pseudo organ that has been grown and harvested outside of the body. And you can do this for a variety of different organs.
What would you need? Like, what would be the basic elements that you would need in order, for example, like if I wanted to create like a pseudo organ for myself, let's just go sci-fi. So if I wanted that, what would you need? What would be the minimum amount of information or sample that you would need to harvest from me?
Ooh, that's a good question. So I'm not a specialist in organoids, but you have a few ways that you can do this. So you can have tissue samples that can self-regenerate, which is why I chose the liver, because the liver is one of the more self-propagating organs. So you can take a liver biopsy, seeded on a chip or seeded in a microenvironment and have it grow itself because it's regenerative to a certain extent. You have other things that are not as much, right? And in those instances, you'd have to leverage stem cells or reprogram cells to actually generate these organs relatively de novo, like embryology, right? Like how you grow a fetus. It's the same type of environment. You put them in that and you push the stem cells to becoming what you want them to be. And then when you add in and you create this environment for them, they will essentially not fully recapitulate because there's lacking of stimulus relative to a real human body.
Environment. Yep.
Yeah, the environment's not the same, but you can push them towards things that look like and act similar to the representative organ that you're looking to get. So that's how you would do that.
So I'm going to jump ahead with some of my questions because, I had a few lined up for you. Yeah. I'm quite curious to learn if you believe that in the future we'll see people that will be able to grow like organoids and then take those organoids and then store them in biobanks for like future research. Is this a line that you would see unfolding now? Because you talked about like you can collect samples from people that are like alive today, probably even people that are not alive, but let's not go down that path. Or we can if you want to. I think Halloween is just around the corner, so
yeah, no, I think it's actually worth to go down that path, but we can talk about that.
Okay, that's super. So do you see this as a potential like new line of industry that will unfold, like a commercialized industry that will actually grow organs, and then if you can't use that right away, then you would store it in a biobank, and then that becomes an asset for like another company that wants to have some answers to some of their questions.
Yeah, absolutely. So that exists today, right? It's still in its relative infancy and it's a novel application, but you have established companies whose whole business model is creating organs on a chip or organoid models to be leveraged by other researchers who may want to have access to that. So they will either get samples directly from hospitals or biopsies, or will go to biobanks, or will develop their own, and they eventually will, to your point, develop their own biobanks. So repositories of, grown eyeballs and what have you, that can then be leveraged at any time, not within its immediacy, but for future use going down the road, because our storage and preservation to capacity and technology is already there.
Right. And it's advancing rapidly, I would imagine.
Very, very, very rapidly.
I have a few questions if we go back to like general understanding of what is a biobank, and do we think that biobanks will be an accepted establishment moving forward? And I think if the value is there and if the value is communicated correctly to a wider audience, then we'll definitely see them flourish. But what is your opinion for the people that do know? Are they worried about like people taking their samples and using them for things that they didn't say yes to? So now we're talking about consent. And do you have an impression that sort of varies depending on where you are in the world? Because I know you travel a lot. I know you speak with a lot of people all over the globe. So like I'm Canadian. Are you Canadian, or are you okay? You are Canadian.
Yeah, born and raised in Montreal. Family is from Barbados, but family's from the Caribbean.
But where are you living now?
I live in Montreal.
Okay. So for some reason, I thought you were in the US. Okay. Anyways, that was a tangent. So yes, hello, fellow Canadian.
Hello.
nice to see you. But what is your impression globally around the world? Is it like, are people as open as they are in Canada, or is Canada even considered open?
So this is from the lens of consenting to have their samples stored in biobanks?
Yeah, and used. So maybe we're talking specific or broad consent, because I would imagine some of the biobanks that will come up in the future will be quite keen to get broad consent because we don't know the questions that we'll be asking 10 years from now.
Yeah, that's a great question. It's layered. So I'll try to answer the first one. So the general, to the point, to go back to the original point, that most of the world doesn't know that biobanks really exist. The user experience for most people is you will go to a hospital, you will get a biopsy, you will get a diagnostic, you will get blood drawn, and it kind of just disappears into the ether, into some black box that we call the medical industry, right? Now, what effectively happens is it gets stored and it gets leveraged immediately if necessary, or it gets stored in a biobank and then eventually gets leveraged. And so most people don't understand that there is a repository somewhere with their samples. So that's one thing. The second thing with regards to is there a willingness to do so, whether they, if they could, that extends beyond biobanking itself, and is more in terms of, do people feel comfortable with participating in the medical industry outside of the immediacy of something that affects them directly? And the answer to that is very varied in a variety of places, particularly in populations that are heterogeneous. So if you look at the history of North America, for example, there is a large amount of hesitancy with respect to the medical industry for persons that have predominantly been excluded from the medical industry in the same way, right? So you have a lot of socio-cultural isms of a variety of forms that come into play when it comes to people feeling comfortable with the systems that are supposed to be there to support them. So if you're a minority, traditionally and classically, the medical system and the general system has not been 100% favorable to you. And that has given rise to a lot of skepticism around participation and what is the actual, if I participate, what's going to happen to my samples? How are they going to be leveraged? We have examples of mishandling of populations, whether it be from Tuskegee experiments that were done in the United States, or, very well covered things like Henrietta Lacks and her genetic and her stem cell and her cell lines that gave rise to the HeLa cells, and the misuse and the lack of not representation, but citation towards or return of value to the people who gave rise to these things. We have multiple examples, and they're just not in the United States, around the world. And so the things that affect society play into this. And we see this most predominantly, like I said, in heterogeneous populations where you have this stratification of different groups. And so even in like Europe, if you think about it, for the most part, people consider Europe to be homogenous in terms of its European Caucasian thing. But even within different ethnic groups within there is differences. The Roma, for example, are usually less well represented in participating in the biomedical industry, or in any industry in particular. And so what that gives rise to is kind of like a bias towards the information we have on a population, which means that we study those that are represented. We develop therapies, or we better understand diseases in those populations that are overrepresented. We develop therapies that are optimized for those populations that could sometimes be at the detriment of others.
It is very layered, as you say. So if we just like go back a bit. So one thing is that we have, people from different descents, have a different history. And you pointed out that sometimes, groups that would normally have been labeled a minority group, maybe not anymore, have been sort of misrepresented or even mistreated historically by the healthcare system. And because of that, they are less willing to share their information. And I honestly don't blame them. I mean, why would you? But that does make a bit of a conundrum, as you have also explained now, because if they are become less willing, then the future of medicine is evolving so fast that if they don't share their samples, then they're essentially going to exclude themselves from having solutions that also include them and help them in the future. So it is a really big issue.
It's it's almost like a self-fulfilling exacerbation of an issue.
Yeah, it's a vicious cycle for sure.
So there's two things, but there's one. So there's a socio psychological aspect to you said in terms of lack of trust, but there's also this concept of donating for the medical industry is really an altruistic event, right? Unless, again, I said, it goes directly to you as a cancer biopsy patient, all that kind of stuff. But for the most part, it's altruistic. And altruism is a product of privilege. And so this is what compounds things that further exacerbate this lack of representation is if you're not privileged enough to have the bandwidth to say, you know what, I'm going to contribute. I'm going to spend my time, which can be multiple hours and multiple iterations, to go and donate my samples. If you don't have that time, you won't do it. And so there's like, again, these social cultural aspects impact how we have this, but we're kind of moving further and further away from it. I think that given better frameworks, people would be more willing generally to donate and participate in the medical industry. And this is where I think aspects of open science that kind of bring the public closer to understanding what happens in the scientific realm, not just medicine, but science in general, is one of the key steps to break down those barriers to really understand, well, this is the value to yourself, to others, to your community, to whatever demographic, whatever kind of focus point is synergizing with you. This is how this can help. And that hopefully will bring it down. And then you have other things like aligning incentives.
Yeah. And that, I think that's a huge task, because that's also a marketing and branding task that it's not only for you at AminoChain and DeSci World that have to address that. It's many initiatives globally that have to address this. But there's something that you said about, okay, you brought up an example of a cancer patient giving a biopsy. What is your opinion regarding, like, if someone gives a sample and then that sample is stored, it's reused at a later time by said company or said research team, and there is some really insightful information. Do you think it's ethically responsible for those that hold that information to communicate it back to the one that gave the sample? And have you guys had discussions around that?
So I'll answer that last one first. So I actually had a discussion around that with a biobank yesterday.
Perfect.
So it's top of mind. So I think that ethically, yes. So I guess for context, when you give a sample and it's leveraged for research, there's this thing called return of incidental findings, where if if something is discovered where, let's say, you have a predisposition to a disease that was not originally sought after by giving your donation or your biopsy, the medical industry kind of tackles with this idea of, should we return that knowledge to the patient? Is it owed to the patient? Should the patient be aware? And all that kind of stuff. And what's the best way to do that? So there are very strict standards that exist in the world where that can be done, but it has to be done by a medical clinical professional, not necessarily a researcher, because the implication that a researcher discovers an incidental finding around it may not necessarily translate in the same way to a clinical application. And so oftentimes when we're talking about, research use of samples, there has to be that discourse between the scientist and the clinician, or a potential clinician, and then that's to determine whether it goes back to the patient. Now, the third component of that being the patient, some people do, some people don't want to know. And you have to take into consideration. So usually within a consent framework, or in some consent frameworks, a patient will have the opportunity to say, if you find anything, do let me know, or don't let me know because I don't want to know. And that has to be upheld. And so ethically, it depends on the scenario. It depends on the situation. It depends on the viability of the incidental finding in terms of impacting a patient.
Right. And then, as you said, there also needs to be a means of communication. And yes, that raises extra technological layers and operational layers. And so it really gets complicated.
So we can go into that because you did mention consent. So consent for those is when you go and say, I give the right for my sample to be leveraged in X type of way. And part of the consent frame, or part of the operational flow, is there's a de-identification that happens of a sample. So, your clinician, your doctor knows that the sample belongs to you, but once it goes into the black box of research, everybody upstream of that is blinded to who you are for your privacy consideration, right? So that's great. But the problem is that it also impedes return.
Right.
Because we don't know where it's supposed to go to. And to your point now, Shelly, there is technology that is coming to fruition that allows individuals to maintain their privacy, but still be recontacted. And, outside of the technology plays, there are some institutions that maintain those links between the researchers and the clinicians. Sometimes as you move further along, it breaks, but there is that relationship. So if a scientist or if a researcher finds something, they can go back to the clinician, and the clinician will be that interface, or even the biobanker, whoever consented the patient will be that interface. Now that's very manual, and it's very, I like to refer to like digital and meat space. That's very meat space, and meat space has its inefficiencies. But there's technology now that is coming to subsidize and support that activity.
Okay. Well, that's good to know, because I think if like when I went through the website on AminoChain, I noticed that there was the possibility, if I read correctly, that you can track like how your biosamples have been used if it's within the AminoChain biobank community. So, and is that the technology that you are referring to now?
Yeah, so AminoChain is an amalgamation of a variety of different technologies that are layered in such a way as to give rise to what we're trying to build. One of which is a network that allows for things like patients to be able to track their sample in relative real time and how it's leveraged. Now, the creation of that robust ability, that robust pipeline to be able to say that, also allows for bidirectional flow. So, in the same way that I can find out how my sample is used, I can also get access to some of the results that are coming off of that sample. Is that guaranteed all the time? No. Sometimes, especially if you've consented for commercial application, you may not be able to get that because there's a commercial contract that prohibits that from happening. And in some other instances, some institutions will not sign into that. So maybe your sample will not get leveraged by a group that says, well, we don't want to have that kind of visibility on how we process things. Which is fine, because then that becomes a dynamic conversation between I don't want to let you use my sample, and that's okay. Whereas today it's gone, and anybody who really gets to use it, it's outside of your consent framework. And you mentioned broad spectrum consent.
Yes.
Which means that you waive your rights to the total sum of how your sample gets leveraged within certain frameworks, right? And it's used because it's easy for institutions. It's easiest for the institution. You say, I can use it however I want within certain boundaries. Cool. I'm going to go do what I need to do. If there's secondary use authorization, that is even broader and means that outside of the initial purpose of the use of the sample, it can then go off and be leveraged. And in the United States in particular, there is a clause in regulation that says that any secondary use, any remnant samples, are no longer considered human samples, or they're no longer considered patient-specific samples, and they can be leveraged however they want. So you have entire brokers, and you have an entire industry of institutions and brokers, data brokers, that will go to hospitals and biobanks, get the leftover remnant samples, and then sell those to pharma to be leveraged, because they no longer have to fit consent frameworks.
Oh, that's pretty wild, actually, that's going on. And
yeah.
Few know about it. I mean, it's not the plot of a very dark movie, but, or I guess it probably could be.
It can be, but to your point, the point is not to say that there's malfeasance going on here.
No,
that's just the framework at how it is. But nowadays, it doesn't have to be. So to kind of tie it back to AminoChain and others that are building similar or relatively similar frameworks in the space. When you create this operating system where a lot of things are interconnected, and you essentially have an auditing trail that links everything that happens around a particular sample and how it's leveraged, what you can do is you can maintain consent frameworks, the terms and conditions of the patient. That's essentially what a consent is really supposed to be. It is a patient giving their terms and conditions of how they feel comfortable for their sample to be leveraged, or that's ethically how they should be. In the AminoChain network, because your authorization is carried along with your sample, you can audit that as it moves through the ecosystem. So for anybody who goes on our website and looks at the demo, our specimen center, which is the user interface, kind of like the Amazon experience for a researcher or a pharma or anybody to kind of find samples that they want to use and leverage them, buy them in batch, whatever, liaise with multiple different biobanks. Within each sample is different authorization. There's different data, metadata, and those include authorization. So authorization for commercial use, authorization for genetic use, and then whatever nuanced details are in the consent framework, those get carried along. And if somebody comes in and says, well, I want to use your sample for XYZ, that is not within your consent framework, your sample will not show up or will not be allowed to be accessed. And so this is how you start to create these things that move beyond broad spectrum consent, which basically just waves it away, to dynamic consent or demonstrated consent, And then further down the line, and we can talk about this potentially if we have time, prosent, where
That's a new
essentially
term.
patients proactively consent their samples to communities that they feel are doing research that may be relevant and they want to participate in. So this is going back to patient engagement, and which are these three frameworks are things that were difficult to do previously because these things were fragmented and disjointed, and there's a lot of handing off physically. But now that you have these more robust guidelines and rails, you can have these novel iterations of what consent could be and what consent will eventually be and have to be. And the world is pushing for it. Open science is being mandated around the world. It's being pushed very heavily. And then with things like the breakdown of 23andMe and all the concerns around, well, what's going to happen to all that genetic data that was gathered, the million or so genetic pieces or genetic information that was gathered from, the genetic information that was gathered from a million different people that is now up for grabs potentially by other companies that want to bail out, or 23andMe will sell to bail themselves out. What happens to that? They are allowed to do that because you signed it away.
That's right. And it's an asset. And if they're going bankrupt, they need to sell it.
So what does that mean? So now your information, essentially your source code, the things that really, the fundamental building blocks of what determines you, who you are, is not out there in the wild for anybody to use in any way, shape, or form. Again, not necessarily the beginning of a horror movie or a villain arc, but maybe.
But I think we've seen like technology can be used in many ways, right? So a lot of great advances that we have experienced in our lifetime has always originally been, put on a path because it's supposed to bring good, it's supposed to bring productivity, it's supposed to help us thrive. And then somehow, somewhere, someone figures out, well, if they just bend it a little bit, then they can make some shortcuts and make a lot of money. And I think that's when the incentives go a little bit awry.
I would respectfully push back and actually offer the opposite. I think a lot of innovation comes from that first piece.
I do too. I think it does. Yeah.
Right. Is profit based. And then sometimes there's after effects that you're like, okay, well, you know what, this could actually be, a lot better for a variety of people. So it depends.
It's usually profit based because it provides some value. Like nobody said, well, I'm going to buy this because I want to make the environment smell really bad. Like no one, that's not the value that you sell, right? So you sell the value that people want in order for them to think that, okay, this is going to help me thrive. I'm going to have a better life, and then somewhere along the line, it gets misused or abused. And I mean, we could say that's the case with email. So we can take something as simple as email and say, well, that was supposed to make our lives easier and better. Now it just consumes our time.
Yeah. And that's a fantastic point, because the third pillar of that is we're not as smart as we think we are.
No.
And a lot of the times, most of the time we're stumbling around in the dark. And then it's only after the fact, like, oh, yes, this might not have been a good idea. Or like, it takes time to learn. And so we're fallible. And that's just part of the human condition.
And I'm really happy that you brought that up, because I know I know what you guys are building. It's, it really has a super great cause. And I think it's something that we all need. But what are the safeguards that you guys are putting into place now? And because you also need to operate with speed, right? Because you have a budget, you have to maintain runway, you have to grow, you have to, this is a service. It doesn't come free. Like, good things cost money. So like, what are the safeguards that you're putting in place, and how do you manage the timeline there with putting in those safeguards?
So it's funny that you mentioned budget.
I can laugh.
Okay, so for context, because we didn't really go into it, but what AminoChain is a network that facilitates data distribution and tissue distribution within the biobanking, between biobanks as well as other stakeholders, so pharma, research, what have you. Okay. So we basically make it easier for people to find the samples that are of interest to them, because that's a very difficult, laborious process. So surface them, acquire them, and leverage them, and then share the data if desired. So we create those more robust pipelines. And so how we like to say it is, and I mentioned before, an operating system for the biomedical, biosample, biotissue space and relevance. It is free for any biobank that has samples to list or to be a part of the network. It is currently free because we're bootstrapping the network for procurers, so people who want to source samples, to use the network. And we've, as a company, have gone back and forth on this idea, because yes, we're not a nonprofit. This is a for-profit, and we have bills to pay. We have employees to people have to live. But we have a significant enough runway where we believe that we can align our interests, or not we can believe. One of our official mandates is to align our interests with public interests. So public interest capitalism, essentially. And so the goal here is to create that robust network that makes all the different stakeholders have at least some exposure to the benefits generated off of these assets. And that's a huge shift in between how it currently works. And in doing so, what that creates is opportunities to actually generate revenue while leaning into this thing. So a good example is clinical recruitment. So that is the process of, if you find an incidental finding, how do I get back to the patient to be able to find and say, hey, listen, would you be open to be recruited into this clinical trial for us to determine, more things about this indication? That is a multi-billion-dollar industry. It is also a very laborious process because of the fact that you have these breakpoints between access. Our network allows that to happen much more seamlessly. And so we don't have to monetize on the base functionality of people being able to collaborate and distribute and all that kind of stuff. But by virtue of the derivatives that get built on top of that, like being able to reconsent, we can monetize off of that. We can give the opportunity and say, well, this is, institute certain revenue models that make it such that, okay, you can do that now. But you'll have to support the ecosystem for that to happen. And that's a net good for the general scientific ecosystem because it pushes everybody up. And then, you have potentially interesting frameworks, and this is a little bit more esoteric and outside of the current framework, but royalty distributions. By the generation of said revenue to the network, you can also create these frameworks where some of that can be redistributed to the patients or the stakeholders that have given access to their samples. And that's something that doesn't really happen nowadays. And return of benefit, I talk about money, but it doesn't have to be money. It could be, again, return of incidental findings. It could be revenue that is not returned to the patient itself, but is put into a pool that a community, like a rare disease community, can then commit towards initiatives that affect their community, both medically or whatever derivation of that there is. There's a lot of ways to align incentives by virtue of having money flow into this network. But the value of the network has to first be bootstrapped. And the value is the people. The value is the institutions. The value is the connectivity. And that has to happen. The best way for that to happen expeditiously is for it to be without barriers. And so that's how we're approaching it currently.
Well, that sounds altruistic, actually, in some sense.
I mean, like I said, we've raised, there's enough. So we're very unique. We're very lucky. It's been serendipitous that the world is converging towards to understanding the value of these frameworks. Like I said, there's open science movement. There's the debacles of companies that have misused private data that has been sourced from public individuals. So there's a generalized push, and that has allowed us to raise substantial capital to allow us to do this in line with public interest. So it is partially luck that is allowing us to really,
right?
It's timing. It's timing. Exactly.
Yeah. And yeah, so we know, I think people, as you said, we know what we don't want, or we have experienced things that we don't want to have repeat. And like you said, there's a lot of different, tangents and trajectories that have momentum now. One of them, which you say, is open science, and not everybody really understands what is meant by that term, open science. I think maybe it'd be really nice if you could share a few words on what you see or how you define open science.
Yeah, so I think everybody has a slightly different definition of open science, and it depends where you are in the scientific framework. I think generally speaking, open science is a reduction in barriers to access science. That could be both for scientists within the scientific realm. and for laypersons, so those who are not formally trained scientists. So it is essentially making it as openly accessible as possible within proper, ethical guidelines for people to participate in science. So open science from the research perspective is if I publish something, I can publish it under a non-open science framework where people have to pay to access it, so publications, or you can do so from a framework where people don't have to pay. And so it can be freely viewed by anybody. Now, noble blocks and persons like yourself understand the pitfalls that exist in the current frameworks, even within open science. For those of you who don't know, when a scientist wants to be altruistic and commit their research to an open access journal, open access means it's easy, it's free for anybody else to read. They actually have to pay additional costs for that. So somebody has to pay somewhere. These open access journals are not doing it altruistically for people. And so if it's not the readers who pay, it's the scientists that pay. And the scientists are already shackled by limited budgeting. So there are persons like yourself and others in the open science, decentralized science ecosystem that are looking to build better frameworks that allow for open science to occur while still allowing people to make ends meet. Yes. And for science to happen. And that's not a trivial thing. It's difficult. So open science, again, to me, and I think for most, is the reduction in the barrier for people to access things in science. And so UNESCO has a great push had released in their 2021 open report, a push towards open science. And that is to say that any science that is generated, and I think the United States is adopting this at some point, but any research, and most research, comes from public funding. Any research coming from public funding has to be accessible by the public. And that just kind of makes sense, right? Like if my tax dollars are going into funding research, I shouldn't have to pay more to get access to the stuff that I supported. Same thing. And that is essentially what we're trying to build, similar frameworks for patients. If I've donated to research, I should have, if not a say, because sometimes that doesn't work, an opportunity to participate, to be aware of, to know how my resources are being used, lest I just be looked at as a resource. And we don't want that. People are people. People are valuable. People are essentially what we're doing this for, what we're supposed to be doing this for. They can't just be looked at as resources. Scientists the same way. Scientists are not disposable individuals. We put our heart, soul, blood, time, sacrifice, inordinate amounts, the amount of weekends that I've spent culturing stem cells for things to develop, for people to develop therapies against. There's a lot that goes into that. There needs to be better ways to demonstrate the value and to compensate the contribution and the sacrifice that we as researchers, we as ideators, and everybody else does to participate. And it's been a very asymmetric value flow for the last 50, 60, 70, 100 years.
Yeah.
We got to fix that.
Yeah. So there's a lot of excellent points that were brought up. I think one of them is that, open science sounds fantastic when viewed from one side. But people forget that somebody had to pay for things to be open. So I'm really happy that you brought that up. I was actually quite interested in looking at what would happen like if we didn't do this. Like if people like you, if like AminoChain doesn't exist and companies like AminoChain doesn't exist, and if we didn't have scientists, pushing for open access, or even like when we talk about decentralized science, which we really haven't touched on that term yet, but what should people be aware of? Like if people like us are not pushing, and your colleagues and my colleagues, if they're not pushing, what's the alternative scenario that could emerge potentially?
So we've kind of seen it, right? So in one of my decentralized science presentations that I give, and I think it's on YouTube somewhere, there's a graph that I like to show that shows the decrease in innovation, in like large step innovation that is happening in science. Now, this takes into consideration the fact that as more science gets done, the easier science happens first, and the harder science is what's left over. So it's much harder to make these intuitive leaps. But even when factoring that in, there's just been a precipitous decline in the kind of science that is really groundbreaking. right? Especially in the biomedical realm. And so I like to, and it was one of my mentors who kind of put this idea in my head, but science is a contact sport, right? Yeah, for most scientists, it sometimes feels like we're very secluded in how we operate, but for science to really flourish in the way that it's supposed to, it's a contact sport. And so what that means is the more people on the field playing the game of science, the more likely you are to find these really innovative sparks that generate these massive changes for people, again, across a variety of different verticals. And so open science is that process of allowing more players on the field, more multidisciplinary players on the field. And while creativity is oftentimes a process of the few, so statistically speaking, a smaller team of individuals can be very, very creative in how they come up with solutions. But innovation takes a more exponentially, like a magnitude more individuals operating together once that creativity has been generated. And so what is the alternate of not having open science? Well, less innovation over time and more biased innovation, because we are humans. The things that matter to me may not be the same things that matter to you. So a good example of this is we're talking about longevity a lot. Longevity is a huge focus in the world, right? How do we extend the lives of individuals beyond their, kind of fight against aging? And that's fantastic. But it's a little bit misplaced when people are still dying from preventable diseases.
True.
You can extend the net lifespan of the population, not just individuals, but the net population, by taking some of the allocated funds that are going towards these kind of life extending and redistribute it to places where people are dying from things that can be prevented. And so if you don't open up the frameworks for people in those locations to be able to weigh in on, hey, we're dying from things that you guys have solved, but we don't have access to, and so they're still affecting us, how are we going to have that shift? People are self-interested by nature, and that's okay. That's who we are, and that's fine.
Yeah, that's a fundamental driver. I think we can't not have that.
Exactly. It's a component that drives us forward, but in the same way that you have to have guardrails and things that kind of hedge against that and balance that, that's what open science is hoping to be. That's what decentralized science, as an extension of open science, is trying to be. Put in these guardrails that make it such that whatever your incentives, whatever your alignments are, whatever interests you, what your public interests are, what your personal interests are, can we devise ways to get you the necessary resources to be able to act on that, to better improve yourself and all the people that you care for, and not just have it sequestered by a small group of individuals or a less representative group of individuals.
You mentioned that longevity research is a super hot topic right now. I mean, you see like biohacks, life hacks, thinking hacks, all the hacks that people are trying to adopt, the vitamin hack, the supplement hacks. Would you say in some way that longevity research is part of like a privileged society then? Like if you're focusing on longevity research, it's a very privileged area that you're serving as a privileged niche. And I'm not, maybe I'm trying to stir a little bit here, but
yeah, let's give provision where provision is due. So I would say that first and foremost, longevity is broad, right? Longevity is just increasing lifespan. And you can do that in many different ways. Fighting disease is a process of increasing someone's lifespan. Our lifespan has been increased by virtue of the better medical practices that we have. That is longevity research. But then you have longevity research that kind of goes towards things that are a little bit more esoteric and kind of tick the needle a little bit, right? Like you could live an extra 10, 15 years, right? And that'd be great for you. But the rest of the world cannot afford the kind of therapies that would be necessary for them to achieve the same level of impact. And then living an extra 10 years, does that really change the needle when, again, people are dying decades earlier than that 10 years? So the math doesn't kind of sync up. So there's certain aspects of longevity, which is a broad term, where it's like we could redivert some of these funds, and they're important, they're good, and cool, we can get there. Like that's a focus, but let's get there once everybody is at the same starting point. When we have everybody on equal footing, then let's look at what it is to push. Because right now we have debt, we have medical debt that we have to solve. And a good example of this is within the kind of accelerated innovation realm, decentralized science, open science, you have longevity, but then you have other applications like women's health. Women's health, much like any of these non-majoritary frameworks, has been not as supported as others. And so why 50% of the population has these misconceived mythical medical conditions or medical operations that are not really, that you don't see reflected in other persons in the human race. And there's no reason for that. It stems from isms.
Yes.
And so if we like, why are we talking about let's push these things forward when we have these medical debts, this debt to society that we should first solve? Let's get out of bankruptcy. Let's get out of medical bankruptcy for a variety of people, and not to just frame it in the medical realm. Let's get out of just person bankruptcy. Let's make everybody, or as many people as possible, create the frameworks to allow for people to reach the starting line, or at least reach the equity line, and then let's push the envelope. We could do them concurrently, but let's just make sure that things are properly distributed. So that's kind of got off topic, but.
So how do we get there? No, it's exactly on topic, because I think the whole point of establishing and connecting the biobanks, as you are doing, and building a community, is to support that when we start getting the right samples from the right, from the population, the part that covers the debt, that there is a framework that can receive them and that they can be utilized and shared wherever they need to go. So I think we're exactly where we should be right now. And I was wondering if you mentioned women as being one population that has, maybe been underrepresented in a lot of the medical studies. And what are the others that you know personally?
Ethnicities, different ethnicities. I gave Romas as the example. Anybody who has ever been, any group that has ever been considered at any one point, even today, a lesser class citizen, or by virtue of systemic practices is a lesser class citizen, that translates all the way through.
Yeah. So we have gender, ethnicity.
You have gender, ethnicity. You have,
I guess, age. Maybe
you have age. You have
like rare
preferences. Rare diseases is one. You have certain socio-cultural preferences that will create these divides or these tribes that are then thought as other. Anything like tribalism is a thing in humanity as we go back to it, right? Tribalism is a thing. And so if you're not the dominant tribe, then you are also oftentimes the lesser of whatever gets happened. So that can be and it's multidimensional, right? I'm a male. So I would be privileged off of the back of the male-centric vision of health, but I am also a visible minority, and so fall within the debt that is owed or that is accumulated by virtue of that. So it's not like any one person fits within one framework versus the other necessarily. It's multifactorial, but it's can we service that debt in such a way that we don't have to all be impacted by these things.
What is the messages then that need to be communicated, would you say, in order for that debt to be serviced? So there's the one messaging to society, like citizen science. And then there's the other messages where it puts more pressure on politicians, in policy. Mm-hmm. I think like for a while, like when you brought up, gender or like the X chromosome, basically, if you want to be super specific here.
Yep.
Like I remember being involved in studies or like vetting protocols for studies where like they specifically said, we're not going to run the study on women because of the menses cycle, their menstruation cycle. And even for me, like 10, 15 years ago, I was like, I accepted that. I was like, geez, why did I do that? So what is the messages that we need to start sharing now with people? Like, how do we bridge this?
This is a good example. This podcast and similar podcasts are a good example. I think having the conversation and bringing, and this is where it's to your point about politicians and lobbying, it's important for the general public to understand these frameworks. because scientists are a very small portion of the society, and overburdened by just trying to survive and do what they want and do what they're like mandated to do. We get shift when a large number of people understand that there's a problem and put in the effort to fix that problem. And that's what and to tie it back to open science, that's what open science allows. It allows the conversation to occur in a relatively open forum where people get better educated and have a certain level of scientific literacy to understand, like, hey, I can understand why it's simpler to not leverage women given their physiological predispositions. But is that right? Are we not accounting for the fact that these are individuals that live on the planet with us and therefore deserve the same level of medical care as anybody else? And apply that to whatever demographic you want, right? You need the general population because people will accept it. I know a number of people who are just like, yeah, okay, that makes sense. Or they'll just go with the flow.
Yeah.
Because they don't have, and again, this also comes from an area of privilege. If you have like other things to consider, you're not here like, okay, let me be the superhero of the world. You are bogged down with so many other things. If we can reduce the activation energy needed for you to understand how things that can directly impact you will impact you, it allows you to make those better decisions. It allows you to make informed decisions, just like informed consent. And now, legally is advocating for policy is your ability to have demonstrated consent or demonstrated informed demonstration of how you want things to happen.
I would also argue that, that we're probably further away from the truth than we think that we are if we are not including, a wider variation of, race or ethnicity or geography or age, or like we're really getting further away from the truth.
Yeah. And I think the world is recognizing that. The world is, and this is from a purely capitalistic lens, the world is recognizing it. There is a huge push for access to less represented material in the biomedical space. Not necessarily by virtue of we want to include everybody, but there's something where you can make an argument that if I develop a therapy, a drug, which costs billions of dollars and decades of time to develop, and it's only effective in one demographic, and effective as in it has less off-target effects in one demographic. Well, there's a variety of drugs that get developed that never work, that never get to market because they're not effective in that community, right? They have off-target effects, but maybe they don't have off-target effects in some other communities. And so there's a general click in saying like, well, if we have a more representative playing field, what something that we just spent billions of dollars in to develop for these people and it doesn't work here, well, maybe it'll work here. Maybe we can save this cost and still bring something to market and generate revenue. So from a not so public interest, but still can impact the betterment of everybody, there is a cognitive shift in saying that, okay, no, we actually there's value in generating a variety of samples or having a more representative data set to work on. Now, the problem is how do we find that? And how do we tap into that? And that's where part of where we as AminoChain and some of the other players in the space come into play. So there's examples of that.
Yeah. So if we focus a little bit on AminoChain now, so when was the inception for AminoChain? When you guys were sitting around playing a game of pool?
No.
Is that very?
No.
Is that was it on a napkin in some restaurant?
No. And I will give the origin story of AminoChain. So I am not the founder of AminoChain. I'm part of the founding team, but I'm not the founder. The founder of AminoChain is a very charismatic young man named Casper Barnes. Casper has this origin story, which is like a hallmark origin story, but very true, where he was born in Vienna, but lived in South Africa for a very long time. And in post-apartheid South Africa, so his family was always involved in community service. His mother is the founder of a nonprofit that helped women with AIDS find support for their families when they were going through the process of their therapies. So they had oftentimes conversations as a privileged European-backed family, this kind of understanding of this divide between culture and isms that exist there. So Casper, when he was young, developed a myeloma. I think it's myeloma. He had a
Mm-hmm.
cancer. Underwent therapy. It was caught super early. It was fine, but he retells this and saying that he remembers waking up after the operation in the hospital with a doctor showing his biopsy. So the piece of the melanoma that they took off of him, and him being like, "Oh, this is super cool. Can I have it? I'd like to show it to my friends in school and whatnot." And the doctor's saying, "No, we can't. Like, it's going to be used for diagnostics and then eventually research." And his parents consented. His mother consented for it to be used. Fast forward, Casper is now in university, and he's holding he was working in a B-cell lymphoma lab, and he was holding a de-identified sample of a patient. And this tracks back full circle to when he was young and being like, I have this, that the person who donated has no idea how this is being leveraged and the type of benefit and impact that it is generating potentially for the world. And so that's what seeded the idea of needing to create a system that has this connectivity where all the different stakeholders are sharers in the benefit or in the impact of how these things happen. Now, fast forward a little bit, there's the decentralized science movement. There's the application of novel technology that allows this to happen much more efficiently than previously. And so he and our other co-founder, Max, who is an even younger gentleman, almost fresh out of high school, brilliant engineer, meet at a hackathon to devise what was to become the eventual product that is AminoChain. And then through operating in the decentralized science space, which I've been in for the last almost 3 years now, we came in contact. And I've always had an aspiration for, my background is I'm a neuroimmunologist, worked in biotech, built leveraging building stem cell platforms for diagnostic research. And so liaise with a lot of biobanks to get those samples. Seeing the issues that exist there, I always thought that the application of novel technologies could solve this. And so it was just to your point, it was a luck. It was a serendipitous luck where I was put in contact with Casper and then Max, and we were talking about this and kind of brainstorming. And they already had the idea of AminoChain and some of the prototype up and running. And then they were just like, "Hey, do you want to do this together?" And we formed I joined the team, and we've been expanding ever since. And most recently, we closed some funding and have since expanded the team and brought on some heavy hitters from the biobanking and tissue procurement space. And so now we're just going out and trying to change the little piece of the world that we think that we can affect with our technology.
So maybe now would be a good time if you could explain, like, what is AminoChain? And well, you have done that already in bits and pieces, but I'm quite curious to learn, like, how is it that AminoChain is leveraging blockchain technology? Because that essentially is part of the name AminoChain. So how does that come? So you have holding sample in the lab, here it is again, to meeting brilliant engineer, to meeting you, and then you're like, okay, well, this has to go on chain. So how does that all come together?
AminoChain is not its own blockchain. Okay, so let's just get that out the way. It is a play on words of interconnectivity. And because we do leverage blockchain within the multitude of other things that we leverage, we thought it fit. So what AminoChain is again, an interconnectivity. We are building the pipelines, the technological pipelines that allow for streamlining data sharing and tissue surfacing and procurement. The piece within that the blockchain kind of holds is the proof of provenance. So it is the ledger that tracks what happens to a sample and more so where it gets utilized in the ecosystem. And that's it. We don't put medical data. We don't have access to. We can have access to medical data, but that's behind privacy walls. But we don't put the data itself on chain. We just allow the blockchain to show and surface where it's been leveraged. So that's the piece where the patient can leverage, the patient can use, and institutions can use to see where their samples are going. That's what that is.
Okay, so the blockchain technology is like just a part of all of the technologies that you guys are incorporating, because it is a very massive undertaking that you are doing, but somebody has to do it because the alternative would be I suppose, not very pretty, as we have discussed.
No, and we're not the only ones doing it, and we're not the originators of this, right? The idea that we need better harmonization structures between not just biobanks, but everything has existed for a long time. We are putting our hats in the ring and think that we have a very strong, viable chance by virtue of leveraging things that people don't usually leverage to do so. And so we're doing it. And so within that stack is data harmonization, schema building to allow for better searchability, the blockchain piece to allow for a ledger of record to how things get leveraged. AI to a certain extent. We're leveraging AI as well. And we're very much open to leveraging things that other people have done. So one of the key parts of the AminoChain network is that at a certain level, it is a composable framework. It can plug into other people's solutions to kind of help synergize and become more than the sum of our parts. So a good example of this in the realm of open and decentralized sciences, you have people who are building self-custody vaults for medical records, where the patient owns the total sum of their medical records, is maintained within their custody. And it is oftentimes positioned or propositioned in a way such that if somebody wants to leverage it or get access to it for research purposes, then they have to liaise with you. There is no such thing as going around the patient. The terms and considerations of the patient are de facto there by virtue of that liaising. And so how that fits with AminoChain is we're not developing that, but we can create the channels that make it easier for people who would be looking to access that, find an easy way to access that or an easier way to access that. So we don't think we can solve it all, but we're very confident where we can solve one piece of a larger picture. And we're building in such a way as to make it composable with other people who are trying to solve other pieces. And that to me is another example of open science, leaning into the fact that is a multidisciplinary science, is a contact sport. Not any one person can't solve it. Any one team can't solve it. So we have to work together to do so. And I think as we do that, this network, and we've seen network effects. We know now that networks are one of the most powerful aggregations of things. Like there's value in networks. You will generate the revenue, you will generate the sustainability for each of the individual parts by virtue of being in a very strong network. And so that's why we're leaning very heavily on building said network.
Oh, it sounds so exciting. So let's say an individual is considering to volunteer for a study where they will have biosamples taken. What would be like your advice to them when considering this? Like knowing what you know now, knowing everything that you've been exposed to, knowing what's going to happen in the future. You clearly have an understanding that people are going to start taking much more ownership of their data in the future. That's like probably another podcast topic. So what would you give advice to people now, like when they're considering to participate in a study? Should they look for something? Should they be aware of something?
Yeah, I would spend the time, as with anything, read your contracts, read your consent frameworks, read your terms and service, educate yourselves on different forms of consent that exist out there, and then find the ones that align with you in the particularities of what you're going to do. So if you're a cancer patient and you need to give your biopsy to determine a therapy, you don't necessarily care that like you're within a position where you just need this solved. If you're, on the other hand, somebody who is going to a direct-to-consumer genetics company like 23andMe, like Ancestry.com, and what have you, and are thinking of, hey, I'm just going to use this to know what my genetic background is, what my family history is, that's fine. But understand that you're giving away something that may have further depth into it. And maybe you should consider, well, in what ways are you allowing this third-party entity who may not have the same interests as you, that may not align with yours, in giving them the capacity to leverage it. Read up about history about how this happens. 23andMe is a good example. 23andMe is not an evil company. They didn't go out and try to screw over people. They had a business model. People acquiesced to it. Their business is failing. And so by virtue of that, now they have to sell off their assets. Take this as an education piece to understand that if you're giving away the most fundamental piece of you, what that may mean down the line. And so the advice is different. Just take the time to educate yourself. Don't look at try not to look at just the surface appeal of like, I know my heritage, and look at like, hey, your DNA is there's nothing more personal than you. It is literally what defines the difference between you, your parents, me, Shelly, everybody. So that is more precious than your fingerprint, more precious than your social insurance number and any equivalent around the world. Think about it like that. You don't give your social insurance number to anybody. Why would you give your genetics to anybody for something as relatively shallow as your family history? So things to keep in mind.
Yeah. All right. I think that was very good advice. I think we need to like weigh like what if it seems too easy, then
yeah, and I mean it comes with literacy, right? It comes with literacy. People don't know. People don't know. A bunch of my families did it. I told them personally because I had my misgivings, I had my personal perspectives, but they didn't understand. Maybe I didn't convey it away, or they didn't see the importance because they don't have the particular the perspective that I had, and it's an amalgamation of things.
Yeah, but I think it's also fair to say too that like your DNA is, like you said, it's code, and when it executes, it typically executes in an environment, and there's so many different ways that execution can unfold in a different environment. So we have to remember it's only part of the puzzle. So I know when you say like you're giving away like the most precious part of me, that statement might be true, but you know, to regrow a Shelley or to regrow a Jelani, I mean, that's something sci-fi-ish. And I'm not saying it's not impossible, because I'll never say it's impossible, but I think we just have to also make sure that people are aware that it's not like you're giving everything away. Like
no, you're not.
There is a lot of environmental factors that come into play here as well. So
yeah.
Yes.
Well, let's get sci-fi really quick before we end off. Let's get sci-fi really quick because
let's
why
go.
not, right?
Let's go.
In the era of gene editing, where I can edit the genetic code, if I know your sequence, Shelly, I can, in theory, over vast amounts of or significant amounts of time, which is conceding, rewrite your genetic code into a cell that is not originally yours. I can then leverage organ on a chip technology to grow Shelly's organ. And then as time progresses, I can clone Shelly, just like Dolly was thing. So you're right. And it's very difficult to future proof things. It's just really good to know what could happen. And again, this is very doom and gloomy. The most beautiful benefits, the most impactful changes to the world can come by virtue of the fact that we are sharing our stuff. Right?
Yes.
It is just to be cognizant of both the good and the potential bad. And that's it.
Yes, absolutely. It's just, you know, it's like reaching a certain level of consciousness and understanding, the roles that we have to play. All right. So maybe there'll be a second version of me, but I will be happy if I just have in the future something that, should I get potentially very ill,
yes,
I have the opportunity to recover or regenerate or replace, even if that should be required. But now that we are on the sci-fi track, maybe that leads with my one of my last questions, which is like, what is getting you like the most excited right now? So I know things are picking up speed at AminoChain. You have momentum, so that's a given. But if we think in terms of like where technology is heading generally, or like where society is heading generally, or where you are heading generally as a person, even, what really lights your fire every day? What is getting you super excited right now?
So part of my job at AminoChain is head of BD. So I have the pleasure of traveling around the world, as exhausted as I feel, and meeting biobankers, going to conferences. And I think one of the most exhilarating and vindicating feelings is that no matter which biobank conference or people that I've spoken to over the last year of doing this, they all reference the same issues. All of them. Interoperability, better consent frameworks, patient engagement, distribution, collaboration. All of these things are the pillars of what AminoChain and open science and decentralized science is building. And so the ability to be at the forefront and be able to tell these people that we have solutions, if not built already, because some are, actively being built by some very ingenuitive individuals, and then seeing the light, the skepticism, but the light, come in, that is extremely powerful. And this is what kind of pushes us forward. Personally, the growth by virtue of meeting these individuals and having the conversations of understanding what are some of the nuances that exist jurisdictionally, culturally. So I was just in Australia, for example. And in Australia, there is a huge push to factor in Indigenous and Aboriginal communities in policy. And that extends into medical policy. And so Australia, if you go to a lot of these medical conferences, they show this map of Australia that doesn't break it down on states, but breaks it down on cultural groupings. And it's like, it looks like a mosaic picture, right? And so the ability to have that level of consideration for things that exist outside of the medical industry, but weigh in, so social determinants of health, having that extend to the rest of the world is also something that I feel is very powerful and is very motivating, because we have these examples of these. You go to Norway, you have return of incidental findings. You have frameworks that exist. And it's just seeing those kind of become catch-all in how we operate. So the world, the space is moving for better, like no matter what, towards these things. And that's very powerful to me. And being able to kind of have these conversations in firsthand is fantastic. And then finally, and I'll leave off with this, I think precision medicine is going to be one of the next advents of medicine again. And that is where it's not, here's general therapy that is generated off of a demographic, but this is general therapy this is a therapy generated for Shelley, for Jelani, for whomever. That is, I think, going to change the game in terms of therapeutic impacts and actual improving the quality of how people live and the ability for people to overcome diseases. But it's going to be a very expensive thing for the mid to long term, right? But the thing is if you get the more people that participate in precision medicine, the more representative genetics that we have and information that we have, that can allow us to offset that cost. So when I go in and I take, if I'm privileged enough to be able to afford a precision medicine endeavor, I go in, my records are maintained. Anybody who has genetics close to me can subsidize that cost because it takes less time to identify the commonalities between the two of us. So you don't have to do all the tests. You don't have to put in all that money. So that brings down the cost. That is another extremely exciting thing in being able to create these interoperable frameworks. These ways to include more people, have better representation, means that precision medicine, which can arguably be one of the most impactful applications, happens sooner and with less barriers to entry for most people. And so I'll just leave off with that.
Oh, that's super interesting. It's like, what are the principal components that we essentially need in order to have this massive representation so that someone like you or has, shared background can say, well, because Jelani, took the time, I can benefit from that too now.
Exactly.
Yeah.
Compounding effects.
Absolutely.
So.
All right. Well, thank you so much for, explaining and going deep and taking the time to, put things in terms that people can understand. And I really hope that they check you out. And the next time someone considers a study, they'll be like, oh, I really hope AminoChain is going to connect my data.
Yeah, I can only hope. I mean, it was a pleasure, Shelly. Thank you. And yes, for those who are interested, I'm always keen to talk about this. You can find me on Twitter. You can find me on LinkedIn. You can find me on places. Shoot a message.
We'll put your details below. Yeah, absolutely.
Cool.
Thank you.
You're very welcome, Shelly.